Hello and welcome back to module number 2. And this module, I'm going to talk about descriptive statistics. I know that most of you already know descriptive statistics. I just want to make sure that everyone is understand and have a full competency on the subject. And the second part, in this lecture, I'm going to talk about R and how we apply that, and I'm going to show you how to run the code in R and how to apply that. So let's begin. Descriptive statistics. As you remember, descriptive statistics is about the mean, median, and mode, and usually we often apply the standard deviation. But the issue is that for me is really important is that I want again to show you the structure of the analysis in order for you to understand when it comes to R and when we're applying a larger set of data, why is it so important to use descriptive statistics as the first step in your analysis. So let's begin. Strength and tendency is usually refers to the mean, median, and mode. And the issue with that is that the mean is the most common measurement of central tendency. Usually we have a sample size, we have the observed value, and this is how we calculate. The issue of the mean is that it affected by extreme value or outlier, which something it is really important to remember. The median in comparison is usually ordered based on 50% above, 50% below, and it does not affect by extreme value, so that's why it is so important. Finding the median, again, it's n plus 1 divided by 2. If the number of value is odd, the median is the middle number. If the number of value is even, the median is the average of the two middle numbers. And again, this is an easy way for you to calculate that. And the last part is the mode. It is the value that occur most often, and it is not affected by extreme value. And it can be either numerical or categorical data. And a good example is if you are planning to buy a house, you're looking at 5 houses near the beach, and each house has a different price, even though in this case the two last listings has the same price. So if we will calculate the mean, we will have to divide it by 5. If we will calculate the median, the number will be in the middle, and the mode is the two last houses that rank the same price. So the mean is generally most used unless extreme value. The median is used since it's not sensitive to extreme houses. Another way for us to calculate this data set or simple data set is use quartiles. Usually the quartiles divide the data set into 4 segments, and each segment equal 25%. So we have quartile 1, quartile 2, and quartile 3, and each one of them represent a value. In case of quartile 1, 25% of the observation that are similar and 75% are smaller. So quartile 1 is, the formula is n plus 1 divided by 4. Quartile 2 is n plus 1 divided by 2. Quartile 3 is 3 multiplied by n plus 1 divided by 4, where n is the number of values that we encounter. For example, we have a sample array of numbers, and we like to do that. My mistake in the numbers in this case, n is equal 9, so it's 9 plus 1 divided by 4, and it's 2.5. So the next number is quartile 1 is equal to 12.5. The second part is the idea of the spread of the value of the data in order for us to do that. In this case, we are looking at descriptive statistics formula in the case of range, interquartile range, variance, standard deviation, and coefficient of variance. So range is a very simple formula, which is the simple measurements of variance, the largest minus the smallest, 14 minus 1 equals 13, and this is the range. The disadvantage of the range is that ignore the way the data are distributed in that set. We do not have any sense and we do not have any range or the idea of distribution of the data. The next one is the interquartile range. Is the idea that we will take the quartile, we will divide the quartile into 4 parts, and we will take quartile 3 minus quartile 1 in order for us to find the interquartile range. So in this case, 57 minus 30 equals 27, and that will be the interquartile range, which will give us the range between quartile 1 to quartile 3. And again, this is important because it will give us the idea how is the spread of the distribution, not on the entire set, but only on the 50% of the data set. Okay, so now become a little bit more complex, and when we are talking about variance, and the formula for variance is quite simple. X is each score, x squared is the mean of the average, n is the number of value, and we have the sum across the value, which what we are trying to do. Standard deviation is the square root of the deviation, which means it is the most common use to measure the variation. So the idea here is that we have a set of numbers, we have n equal 18 and the mean is equal 16 in order for us to calculate that is around 4.246, and this is how we find it. So the variance is the distribution of the data. We can have small standard deviation or we can have large data deviation. And again, comparing standard deviation can give us a more insight into the data set, because the mean by itself does not give us, in this example, the 3 data set as the same mean, but when we are looking at the standard deviation, it tell us another story. So in this case, a story of where is the distribution, the average distribution is laid out. So the advantage and the disadvantage, each value of the set data is used in the calculation. The values are far from the mean, giving extra weight, and this is important that we encounter that. The last calculation or last formula in this set is the coefficient of variance. It is always in percentage. It shows the variation relative to the mean. So we are trying to see where it stands with regard to the mean. So we divided S divided by x squared multiplied by 100% in order for us to find the coefficient. So the idea here is it's often used in the business world where they compare stock A to stock B, and in this case, where does it stand with regard to the overall performance. So the shape of the distribution, we have how the data is distributed, measure of the shape, it can be a screw to the right or screw to the left. When the medium is bigger, this is how we see it. When the mean equal to the medium or the medium is bigger than the mean, this is how we will see it. And again, I want you to have a sense how it will be shaped. One of the things that usually the introduction to statistics often forget about is empirical rule, which means that if the distribution is a bell shape, then the interval is equal to, has the ability to contain 68% of the value of the population of the sample. So the empirical rule is its ability to find out 99.7% of the value of the population in compared to the sample, or 95%. And that will come back to us later on when we are trying to apply or calculate hypotheses or try to conduct a more serious analysis with regard to the hypothesis that we will state. Okay. Second part of my lecture today is about open source R. So, as I said beforehand, or as I started to say in the first class, the R is, again, it's considered to be not a machine language. It is not, it's a assembly language, which means that the idea here, it is considered to be high-level language, which has instruction closer to everyday language. And the struggle or the objective in my class that I want to overcome it is that I want you to have that language, the content of the language in the context of the statistics, in order for you to apply or to understand why are we writing our code in the way we do. So, higher level, we often talk about COBOL language or Pastel language, and again, the code and the syntax is really important to how we come up or write our code in order for us to be more reliable or to be more transparent. In R, what we are doing, we are storing inside the R object the data set. So, example, if you can save data into object like A or B, then you'll be able to run the code or to run the formula in a way that it will reflect the object and not lay out every time the entire data set. So whenever you encounter an object, you can replace it with a data set that you already saved inside. So in this case, the A is the content of A at 1, and so in this case I can add A plus 2, and in order for me to allow that. Bad names versus good names. Good names usually are short and easy to remember. Do not try to be choose names that can cause errors or misunderstanding, especially when your code has been shared not only by your professor but with your peers in the class. It's usually important that you will have a good name so everyone will understand it. One of the basic things that we need to remember in any functional programming language is a function is a name of a section of a program that performs specific task. In this sense, a function is a type of procedure or routine that is often applied. The idea here is that in R, we have many already embedded functions that allowed us to do that. Example, mean is an embedded function. Everyone knows that we do not need to write the code for the mean in order for us to calculate. R will recognize this function and apply this function. Example, the mean of 1, 2, 3. R will know that 1, 2, 3 is the data set and the mean is the function, in this case, mean of the numbers, in order for us to do that. Again, another example of a function that already embedded in R is the factorial. N square, and in this case it will remember the entire set and it will list, if you want to do the set, it will be able to do that. Here is a list of all the functions in R. It is very useful. Crane is where all the documentation, all the R packages are stored. This is basically your Google search engine is the Crane. Crane is where you will find all the documentation, and everyone has his own preferences. I like the Crane as my own, so I gave you another reference for a list that can be useful. Again, the R functions. The data that you pass into the function is called the function arguments. So in this case, we can have the argument or the function argument in order for us to do that. And again, the function can have multiple functions. In example number 2, after the example of the mean, you see factorial, and then I open up to another function called mean in order for me to calculate the outline. So you can, one of the greatest assets of R is the ability to write your own function, which is extremely important, because a function, if it's popular, it can become part of the R community terminology, and that's the objective of all the R community members. So again, we can use the writing our own function, example, a sample, and I will write what is a replacement, what is the size of the size of the replacement, and I can assign what is the data set that I want it to run based on it in order for you to do that. So a function in R are the first class object, which means that they can treat much like any other R object, and the return value of a function is the last expression in the function body to be involved. So every function in R has 3 parts: a name, really important, a body, and a set of argument. To make your own function, you need to replicate those parts and store them in R. So the syntax of R, the syntax of function in R is that the function has to have a name argument, which probably have a default name. The formal argument of the argument included in the function definition, which you need to declare to the R, and the formal function return is a list of all the formal arguments of the function. Not every function called for in R makes it use of the formal arguments. Functional arguments can be missing or might have a default value. That's something that we need to address. Another aspect of R is the vector. A vector is a sequence of data elements of the same type of data. Example, 2, 3, and 4 is a vector. The number in the vector are usually called compounds, and usually they are called them number in this side. So in this side, in my was for my book, and that's how I phrase it. So here is a vector contain 3 numerical values, and as you can see, we can add vector of a logical values to this. So we can add true or false, and it will be addressed as a vector. And we can add AA or BB or CC, and again, this is part of a vector. We can use a logical vector as an index, again, to make sure that we are coherent with our calculation, and make sure that we are provide logical or attributes to the arguments that we are trying to do. You can always modify a vector, and doing so you can modify the elements in this example, or create four elements in addition to it. So it is not a set of rules. You can always change the vector in order for you to do that. You can also delete the vector if you need to. So a list in R is a list of generic vector containing other object. For example, this is a list 2, 3, and 5. or it can be a list of AA, BB, CC, or even names, or it can be even true, false, and it also can contain copies of it. So again, there is no direction, but list is part of our way for us to do that. Import data is part of the essence. In the past, we did not have the RStudio, so we used to write it as a code in the data set, and we used to write it read table from directions. And from Excel, in the past, we did not accept Excel. Nowadays, RStudio accepts Excel. So let me go back to the RStudio. I hope that by now everyone has the RStudio interface. And so you can see you have basically 4 windows. The first is where you're going to write your code, and the console is what runs behind the scene. Basically, when you're running a code, for example, x is equal to a list of numbers, you will see that the console accepts that and adopt it into it. In the other windows on the right side is the environment, which can be your data set, or the connection that you can make, or the help that you might need. And so this is something that you allowed you to apply. Packages is something that we are going to use quite a lot, and there is a lot of packages. There are around 10,000 packages that people wrote and people apply. If you look at part of my packages that I wrote, you will see that. And we will use only basic or popular packages such as ggplot2 or more advanced statistical and analytic packages in order for you to do that. But we also will use packages to use for data set. Example, there's a very famous data set for old cars. It's quite simple, but you need to have a package in order for you to upload. You can also create your own plots in the window environment, and you can also upload, see your data set and how it be applied, and you can also upload your own data set and see what it is entail. So in order for you to import new data set, example, I don't have with me, I did not prepared Excel, but in order for you to import Excel, you will import the Excel from here, you upload it, and it will be adapted. I will go over that later on and make sure that you know how to do that. It can be done, and it's quite easy. The interface of RStudio is quite easy and to apply and really straightforward. Okay, so now to the assignment. In the you have an assignment how to calculate. You have a data set that I gave you. You're going to lay out the data set and you're going to run it, as I said before. And then the y, and as I said, mean is already a function that's embedded into the R. So you only need to highlight to the R that you want to run the mean for the X and mean for the Y. And if you want to do standard deviation, you need to know the code, and I lay out all the components of the standard deviation, the medium, the mode, and everything else. And again, this is what you will see and how to apply that. You're going to use the R for that, and you're going to develop it through R, and making sure that you capture a screenshot of the RStudio that you worked. See if you had problems. If you had problems, please let me know. My job is not only teach you statistics and R, it's also to help you to overcome those problems, and I'll be more than happy to do that. So this is it for the the second module. I hope you enjoy it. Until next time, have fun. Whew.